Hi everyone, welcome to my channel. We were discussing the important question and answers of the topic BJT regarding this basic electronics course. So we have discussed in the previous videos about 4 questions. We'll continue with the next question. So next question is one of the important question, that is the configurations of the transistors, or the transistor characters will represent the relationship between the different DC currents and voltages of transistor. So there are three important characters. There will be three important characters. So in these three important characteristics, which we name it as static characteristics of transistors. So here we will have the input characteristics, the output characteristics, and the transfer characteristics, that is the constant current transfer characteristics. So these three important characteristics, which we name it as static characteristics, will take upon three different configurations. With respect to three different configurations, we can analyze these characteristics of a transistors, the static characteristics of the transistors. So among those three configurations, now we will be studying one of the configuration, that is common base configuration. So how we are studying this common base configuration? So you can see this is the circuit what we write for the common base. So base we take it as a common, and here we have two different circuits, that is two different supplies here are given, VE and VCC. So the base will be common, and here it will be the base emitter junction, and here the collector base junction. So this is the circuit diagram. We are doing it in a lab experiment, so we will be connecting these voltmeters and milliammeters across the different voltages and currents. So this will be the voltmeter, which is used to measure the base emitter voltages. This is the milliammeter, which is used to measure the currents which is entering. Then this will be the output voltmeter, which measures the VCB, and this is milliammeter, which measures the output current. So this will be your experimental setup, the circuit which we rigor for common base configuration analysis, static characteristics of transistor. So here, as I told, we'll have the input characteristics and output characteristics. So to investigate the input characteristics, what we do is, here in this, the connection or the circuit we have connected is always the base emitter junction. This base emitter junction will be forward biased, and collector base junction will be reverse biased, so that the IE current flows into the input circuit, and IC flows into the output circuit. So these are the things what we are connecting this NPN in common base configuration. So next, how we draw the output characteristics, input characteristics. So how we draw this input characteristics? So it is the curve which we take up between the emitter current is emitter current and the emitter base voltage. So input characteristics in the common base configuration taking the curve between the emitter current IE and the emitter base voltage VBE at constant VCB, that is constant collector base. So for this constant collector base voltage 0, this is the curve, and for constant collector base voltage 1 volts, this is the curve, and for 6 volts, this is the curve. Like that, we are going to write the characteristics, input characteristics. So after this, how we are going to record and how we are going to get this particular curve is, we have kept this VCB constant for certain voltage. Then we increase the input voltage. Is the input voltage, that is nothing but your VBE in small steps. Then corresponding input current, that is IE, will be. So for any small changes of this input voltage, what is the input current? So this is how we are going to take, and we are going to take those points, and then we are going to plot the graph for certain constant VCB. Then we change this VCB to another volt. For example, if initially it was 0, I will change it to 1 volt, and then again I follow the same steps. Increase the VBE, and then corresponding reading of IE is noted down. So like this, we will get a different points, and if you are drawing a smooth curve, get that input curve, which is between the VBE versus the IE increases rapidly. The IE will increase rapidly, this portion. So IE increases rapidly with small increase in VBE. So small increase in VBE, IE increases rapidly. So it means that the input resistance is that whatever your input resistance is very small. Resistance is very small. So therefore, your input resistance are high, nothing but small change in E to the change in IE for the constant VCB. So this is how we draw the input characteristics. So input characteristics of next, we are going to draw the output characteristics of the common base configuration of the transistor. So how we get this output characteristics is, here we are taking IE as constant, we are keeping IE as constant, that is the emitter current. So IE, keep it for certain value, maybe 1 milliamps, 2 milliamps. Likewise, we are going to keep it constant for certain value of current. We are getting the curve which is the relationship between the collector current and the collector to base. So collector current and collector to base voltage for constant value of I. Here also By keeping IE constant and by varying the collector current variation of the PCB, we are plotting the, and here also you get the output resistance. So like this we are drawing the output characteristics. So here also your output resistance CB by C or constant. Okay. And here the output region will be divided into three regions. Output characteristics, that is saturation region, active region, and the cutoff region or the breakdown region. So what is this saturation region? The transistor works as the switch, that is on condition and off condition in saturation and cutoff region. Okay. So in saturation and cutoff region, a transistor works as switch, that is here it is off and here it is. In the active region, the transistor works as an amplifier. So transistor works as an amplifier. It's nothing but in your saturation region, what happens? The VCB is negative for NPN transistor, and that is nothing but your collector base junction will be forward biased in saturation. So small change in VCB results in large change in the IC. Then in the active region, the base emitter junction, base emitter will be forward biased and collector base will be reverse biased, and IC is constant and equal to constant. So here your IC will be equal to, and in the cutoff region both junctions of transistors are reverse biased, hence only there will be small leakage current which flows in the circuit. So this is your output characteristics of common base configuration. So this is also one of the important questions they might ask.